Welcome back to the course Engineering Chemistry. Myself Dr. Harika, Assistant Professor, Department of Chemistry, MLR Institute of Technology, Hyderabad. In previous class, we have discussed about the introduction to the corrosion. In today's class, we are going to discuss about the dry corrosion, which is a mechanism of corrosion. Mechanism of corrosion involves two steps. One is dry corrosion and other is the wet corrosion. In dry corrosion, we are going to learn about the three topics: oxidative corrosion, corrosion by other gases, and liquid metal corrosion. Dry corrosion is also called as chemical corrosion or direct chemical attack theory. It involves three steps, three subdivisions. One is oxidative corrosion, corrosion by other gases, liquid metal corrosion. Let us move one by one. What is meant by dry or chemical corrosion? Dry or chemical corrosion, which is nothing but direct chemical action or direct chemical attack theory. Action of atmospheric gases like oxygen, H2S, sulfur dioxide, nitrogen oxides, and anhydrous inorganic liquids with metal surfaces in immediate proximity. So, if a metal surface is surrounded by any oxygen gas or H2S or SO2 or nitrogen oxides, in absence of moisture, dry corrosion takes place in the absence of moisture, in the presence of gases like oxygen, hydrogen sulfide, sulfur dioxide, nitrogen oxide, and anhydrous inorganic liquids. Nothing but one metal liquid can impact corrosion on another metal, which is called dry corrosion. The extent of corrosion depends on chemical affinity, the interaction between the corrosive environment and the solid metals. Corrosive environment is nothing but the gases or liquid metals interaction with another metals. So, if there is an interaction between the gases or liquid metals with a metal surface, there is a chances for the corrosion. Ability of the reaction products on metal surface to form a protective film. So, if gases are reacted with a metal, it forms on certain products, oxide layers. There are the oxide layers which are protective, some of the oxide layers are non-protective. Let us know which metal oxide layers are protective, which metal oxide layers are non-protective, which leads to the further corrosion. Oxidative corrosion. This is the first type of dry corrosion. Oxidative corrosion takes place only in the presence of oxygen. Oxidative corrosion. It occurs by the direct action of oxygen at low temperatures on alkali and alkaline earth metals. There is more proximity between the action of oxygen on the alkali and alkaline earth metals. At higher temperatures, almost all metals are oxidized. Example, lithium, sodium, magnesium. All these metals are easily oxidized because of the atmospheric oxygen. Let us take a metal, M. If it is oxidized, it is going to lose N electrons. If there are the two metal atoms, so it is going to be converted into metal ions. It is going to lose N electrons. These electrons are gained by the oxygen. So, metal is going to be oxidized. Metal is going to be oxidized in the presence of oxygen. Those electrons are gained by the atmospheric oxygen N by 2 O2, which absorbs those N electrons and gets reduced in the form of oxide. This is called reduction. So, metal is going to be oxidized into metal ion and oxygen gains those electrons and gets reduced to oxide. So, metal ion plus oxide gives metallic oxide layer. This is called metallic oxide. There are the various types of metallic oxide layers. Oxidation first occurs at the surface of the metal and the resulting metal oxide scale formed decides the further oxidation to take place or not. If there is a metal, when it is exposed to the corrosive environment, let us take that is in the presence of oxygen. In the presence of oxygen, it has formed an oxide layer. If this oxide layer, which is non-porous, doesn't have any pores, non-porous. If there is another metal formed, reacted with oxygen and formed an oxide layer which is having more porous in nature. If the oxide layer is porous or non-porous decides the further oxidation and corrosion of the metal. This is a non-porous oxide layer. This is the porous oxide layer formed by some other metals. Metal plus oxygen gives metallic oxide. Some of the metals gives corrosion products. Only not all the metals, only some of the metals. A thin layer of 300 Armstrong units of metal oxide. This is a layer of 300 Armstrong's thickness of metal oxide is formed, and the nature of this oxide layer an important role in the further corrosion. So, every metal forms an oxide layer, minimum of 300 Armstrong's units thickness. If this oxide layer decides whether to undergo further corrosion or not, this decision depends upon the metal we have chosen. There are the different types of oxide layers based on the different metals. Let us move to the one of the type of the oxidative corrosion. First one is unstable oxide layer. This is the unstable oxide layer. This unstable oxide layer we are going to see in the presence of silver, gold and platinum. Let us see. The oxide layer formed is decomposed back into the metal and oxygen. So, corrosion is not possible in such a case. So, these are the metals. In this case, these metals forms an oxide layer. These are the oxide layer which decomposes immediately when they are formed. So, corrosion is not possible. You see, if this is a gold, when it is reacted with oxygen, so it is formed an unstable oxide layer. So, a gold oxide layer is formed at the surface. So, which is formed immediately gets decomposed. Decomposition of the metal oxide layer, again we are going to get our own metal and oxygen. No corrosion. There is no chance for the corrosion because these are the metals which forms the unstable oxide layer, that is oxide layer decomposes immediately and we are going to preserve our own gold and platinum or silver. So, these are the long lasting metals. Let us move to the second type of oxidative corrosion. Stable and non-porous oxide layer, which is a non-porous. If you take, there are the metals. Let us take that this is an aluminium. Aluminium is a metal which forms stable and non-porous oxide layer. If this is a aluminium is reacted with, this is non-porous. Stable non-porous oxide layer is formed which adheres tightly to the metal surface. When a metal is forming to the oxide layer which is non-porous, which stick on to the metal surface and impermeable or impervious in nature. Impermeable is nothing but does not allow further reacting with oxygen. When the fresh metal is reacted with oxygen of aluminium, is going to form a non-porous oxide layer. This is the layer which does not allow further reacting with oxygen, does not allow further oxygen to pass through it, which is called impermeable in nature. It is impermeable in nature. So, the metal surface which is having non-porous oxide layer, which is impermeable in nature, it prevents the metal surface from any further contact with atmospheric oxygen. So, this oxide layer prevents further oxidation. It prevents further oxidation, does not allow, first it will react with oxygen. If it forms a non-porous oxide layer, it does not allow the further oxidation. Such a film behaves a protective containing in nature. So, the stable and non-porous oxide layer is also called as protective oxide layer, which is also called as protective oxide layer. thereby shielding the metal surface. So, aluminum, tin, lead, copper, these are the metals which forms the oxide layer which is non-porous and protective, does not allow the further corrosion. Metal plus oxygen gives base metal. What is meant by base metal? Aluminum. The metal we have chosen is base metal. Aluminum, tin, lead, copper, which forms a stable oxide layer which is non-porous oxide layer. Further corrosion will not take place in case of stable non-porous oxide layer. Let us move to the next type of oxide layer, porous oxide layer. So, if this is a metal, stable porous oxide layers have pores. If a metal like lithium is reacted with oxygen, it forms an oxide layer is full of pores. These pores allows further oxidation. So, layer by layer, each layer is going to be oxidized because of the porous oxide layer, which is non-protective. Porous oxide layer is non-protective oxide layer. Stable porous oxide layer have pores or cracks. Atmospheric oxygen have access to underlying surface of the metal through the pores or cracks of the layer. So, atmospheric oxygen, so the further oxygen can undergo into the inside layers, underlying layers surface of the metal through the pores. With the help of these pores, again it will go inside. Again it will react the next layer to the next layer of the metal. It will react to the next layer of the metal. Therefore, inside layers one by one it is going to be oxidized. Thereby corrosion continues unobstructed till all the metal is oxidized. Layer by layer, if it is allowed the oxygen to enter, the corrosion occurs continuously. Example, in the case of alkali and alkaline earth metals like lithium, sodium, potassium, barium, magnesium, calcium. See, if it is this lithium or sodium, sodium metal reacts with oxygen, gives porous oxide layer. This porous oxide layer allows the oxygen, therefore further attack to the pores and cracks continues. So, corrosion occurs in case of these metals. So, in previous case, in case of aluminum, tin, lead, no further corrosion because it is a protective. In case of lithium, sodium, potassium, it is a porous oxide layer and non-productive, further corrosion takes place. Next type of oxidative corrosion is volatile oxide layer. A volatile oxide layer is formed which volatilizes as soon as it is formed, thereby underlying metal surface exposed for the further attack. See, if you take a molybdenum metal, it reacts with oxygen, it forms an oxide layer. This oxide layer easily vaporizes. Molybdenum oxide itself is vaporized. Again, the layer was reduced. Again, it will react with oxygen. There is a further reaction and further reacting with oxygen. So, further corrosion takes place. Layer by layer is going to be vaporized. Thereby underlying metal surface exposed to the further attack. So, if the layer was oxidized or vaporized, thereby underlying metal surface exposed for the further attack. This caused a rapid and continuous corrosion leading to the severe corrosion. Loss of metal. We are going to lose the metal as early as possible because the layer itself is going to be vaporized. Molybdenum oxide. See, if it is a molybdenum metal, if it is going to react with oxygen, so therefore it is going to form a volatile oxide layer, that is the volatile oxide layer is going to be vaporized and there is the metal is ready for the further attack of oxygen. So, a fresh surface exposed for the further attack, so it leads to the corrosion occurs layer by layer. Again the layer was ready for the further attack of oxygen. So, corrosion occurs continuously till the metal was completely evaporated. Let us do the next type of dry corrosion. Corrosion by other gases. Till now we have seen that corrosion by oxygen. Now corrosion by other gases. Oxygen plays an important role. What are the other gases which leads to the corrosion of certain metals? Dry gases like SO2, chlorine gas hydrogen sulfide, fluorine gas, etc. causes corrosion effects on the metal. Extent of corrosion depends upon the chemical affinity between the metal and the gas. The chemical affinity. Some of the metals will react with some gases and leads to the corrosion. Some of the metals reacts with the gases, does not undergo further corrosion. Let us take one of the example is chlorine gas. Chlorine gas, when it is reacted with silver, it gives the silver chloride layer. That is the silver chloride layer which is protective and non-porous. If the same chlorine gas is reacted with a tin, it gives the tin chloride which is volatile and non-protective. So, one of the gas is harmful to the tin. This is the chlorine gas which gives a protective layer to the silver. So, silver does not react further with atmospheric any other gases because the chlorine which is formed a protective layer over it, so it does not undergo any corrosion. If tin reacted with the chlorine which gives a non-protective and porous layers, these are the porous layers which allows the further reacting with further gases which leads to the corrosion. This is nothing but corrosion by other gases. Let us move to the next type of dry corrosion. Liquid metal corrosion. So, here absence of moisture, then what we are going to use? Liquid metal is nothing but one liquid metal and one is the solid metal. Because of the liquid metal, the solid metal is going to be impacted by two ways. It is due to the chemical action of the flowing liquid metal at high temperatures on the solid metal or alloy. It is nothing but the chemical reaction between the liquid metal and the solid metal. Let us take one of the example. The liquid metal is mercury. The solid metal is gold. Dissolution of gold in mercury. Gold is going to be dissolved in the mercury. So, gold is a solid is going to be dissolved in the mercury. So, is nothing but it is one type of liquid metal corrosion. Either liquid penetrate into the solids. A liquid penetrates into the solid. Either solid is going to dissolve in the liquid or liquid is going to be, liquid drops are going to penetrate into the solid. These are the two different types of liquid metal corrosion. Let us take an example. Liquid sodium as a coolant is taken in the nuclear reactor made up of steel. So, this is the sodium liquid is going to penetrate into the steel solid material in the nuclear reactors. So, in this way steel is going to be dissolved or steel is going to be undergo liquid metal corrosion by the liquid sodium. Dissolution of gold in mercury, which is nothing but solid is going to be dissolved in the liquid metal. So, it is of two types, either liquid metal penetrates into the solid metal or solid is going to be dissolved into the liquid metal. It involves internal penetration of the liquid metal into the solid metal or dissolution of solid metal by a liquid metal. Corrosion in the absence of moisture. In today's class, we have discussed about the dry corrosion, which is also called as direct chemical attack theory of corrosion or chemical corrosion, which is also called as chemical corrosion. Here, we have seen that corrosion due to oxygen or which is called as oxidative corrosion. Oxidative corrosion. In the oxidative corrosion, we have seen unstable oxide layer which is formed by the unstable oxide layer which is formed by the silver, gold, platinum, which does not undergo no corrosion, which does not undergo any corrosion. Let us see that stable oxide layer which is also called protective oxide layer or non-porous oxide layer. Non-porous oxide layer which is formed by the aluminum, tin, copper or lead, which does not undergo any further corrosion. Let us move to the next one is porous oxide layer. Porous oxide layer, or we can also call it as non-protective oxide layer. Non-protective. Example is alkali and alkaline earth metals, lithium, sodium, potassium, which undergo further corrosion. And next one is volatile oxide layer. Volatile oxide layer, which is formed by the molybdenum, where the oxide layer which volatiles very easily, therefore it undergoes further corrosion. In these two cases, further corrosion takes place. Further corrosion takes place. In these two cases, no corrosion. There is another type of dry corrosion which is called as corrosion due to other gases. This is the first case, this is the second case. Corrosion due to other gases. We have seen the taken the chlorine is the example. And the third case, corrosion due to liquid metals, which is also called as liquid metal corrosion. We have taken the gold and mercury. Gold is going to be dissolved in the liquid metal, or the liquid sodium penetrates into the steel. Liquid metal corrosion. In next class, we are going to discuss about the other type of mechanism of corrosion called wet corrosion. In wet corrosion, we are going to learn two subtopics: evolution of hydrogen and absorption of oxygen. Thank you.